All right. So this is a quick video for anybody that wants help with dynamics problems involving pulleys. Not pulleys, rather, tensions in strings. That's what I want. So I'm going to do two examples, one without friction, without a force of friction, then I'll do one with friction. So first, for the one with friction, I'm going to make three masses, and I'm going to make them pull by a force of, I don't know, let's say 50 newtons. All right, and I'm going to make those masses. This looks like a 5, and I'm going to say this looks like a 5, and these would be kilograms, I guess. Kilograms. And this looks like a 2. Again, kilograms. So with no friction, that's your diagram. That's your starting point. What you do, so the goal is to find the tension in the strings. Let's call this T1 and this T2. Usually forces are capital F for the symbol, but for tensions I use a capital T. But it doesn't matter. You could use an F as well, F1 and F2. So step one in finding those tensions is always to find the acceleration of the system. So to do that, we treat it as one big fat mass with a 5 and a 5 and a 2, so that's 12 kilograms. And we have a force still of 50 newtons hauling that 12 kilograms forwards. We have a normal force, and we have gravity, but we have no friction backwards because I said this is without friction. So then we write Newton's second law, which is net force equals mass times acceleration. The net force on this is just 50 newtons because there are no backwards forces, and the normal force and gravity cancel each other out. Equals 12 kilograms times the acceleration. So you're essentially going 50 times 12. 50 divided by 12. And I need to just slide over and grab my calculator. Of course, you can pause this at any time and try and do the next step on your own. So 50 divided by 12 is 4.2. So I got the acceleration is 4.2 meters per second squared. All right, that's step one done. Find the acceleration of the system. Just to scroll down a bit and write step 2 is find, let's say T1 first. Actually, I need to see my other diagram there. So to find that first tension, that's the tension that is pulling just the 2 kilogram mass forward. Again, I have the normal force and the force of gravity, but they're just going to cancel each other out and not really matter. And this is T1. So then I'm going to write my net force statement again. I'm going to say F net equals mass times acceleration. The net force this time is just T1 pulling that mass forward, and we've got 2 kilograms. And now we know that the acceleration of the system is 4.2 meters per second squared. We know that's how fast it's accelerating. So that first tension is simply that, 2 times 4.2, which I believe is 8.4. You can check my math there, and that's going to be in newtons. If I scroll down just a little bit, I'm going to also show you how to find T2. So step 3 will be find T2. Now to do that, I'm going to put a mass here, and I'm going to put T2 right here. Now you have to think how much mass is the second tension pulling forwards. And it's both of those, it's the 5 kilogram and the 2 kilograms, so you have to add those together. It's pulling 7 kilograms. And then you just do the same thing as before. You've got your normal force up, you got gravity down, but they don't really matter in this question. So you're going to say F net equals mass times acceleration. Again, Newton's second law. This time the net force pulling this thing forward. Am I treating that as 1? I am treating that as 1. The net force is simply T2. And we're going to equal that to, or equate that to 7 kilograms times 4.2 meters per second squared. And then I can't do that one in my head, not right now. And I got 29 newtons of force of tension on that. That one's done. And that's how you do it with no friction. Next, let's do one with friction. With friction. And I'll do a simpler system. I'll just do it with 2 masses this time. I'll use my same 50 newtons forwards, and this looks like a 2 and a 5 kilogram. I don't know why, just randomly. This is the tension that we're going to try and solve for. I could just call it T this time because there is only one tension, but we'll call it T1 just because. Your first step is the same as before. Find the acceleration of the system. Oh, and this time we do have some friction going backwards. So I'm going to make sure I include that. So I have to tell you something here. I'm going to say that the coefficient of friction is 0.20. There's no units on that. So then on my diagram, or I can write that it's equal to mu times the normal force. So I got 7 kilograms being hauled by 50 newtons forwards. I do have a normal force, and I do have gravity. I need to find gravity because I need to use gravity to find the normal force. I need the normal force to find friction. So it's just m times g, 7 times 9.81. You should have been doing that quite a lot by now. And that gives me about 69 newtons. That means the normal force will balance that at 69 newtons. And that means my force of friction back here is going to be equal to mu times the normal force, which is 0.20 times 69 newtons. Let's move this down just a little bit before I continue. 0.2 times 69 equals 13.8. I'm just going to round it to 14 to simplify this example. So I've got 50 newtons forwards, and I have, I don't like the way I drew my mu there. It's still not great, but I'm going to leave it now. I've got 50 newtons forwards and 14 newtons backwards. So I'm going to write my F net statement maybe over here. F net equals MA. The net force is 50 newtons forwards minus 14 newtons backwards, equals 7 kilograms times the acceleration. So 50 minus 14 is equal to 36. So I put 36 newtons here, equals 7a. 36 divided by 7 is equal to 5.1. So the acceleration equals 5.1 meters per second squared. So that's the acceleration of our system. I'm going to move myself up here. And now I have to find that tension. So I'm just going to give myself a little bit more space. And I'm going to isolate the 5 kilogram mass because it just has tension pulling it forward and it has some friction holding it backwards or pulling it backwards. It's still got the gravity and the normal force. And I'm going to have to calculate those all over again because now it's 5 kilogram mass times 9.81. I go 5 by 9.8. 9.81 equals 49 newtons. 49 newtons. The normal force then is also 49 newtons. It's not a rule that gravity equals the normal force, but it does if there's no other vertical forces. We have to assume that this thing doesn't accelerate up into the air or down into the ground, so they should be balanced in this case. Now back here on friction, I can calculate that. Force of friction equals mu times the normal force. 0.20. Now the friction is going to be less because it's less normal force, times 49 newtons. So I got that times 0.2, and it's going to give me about 9.8, but I'm going to round it to 10 newtons. So I've got friction, I've got everything except tension. The question wants me to find tension. So I write Newton's second law again, F net equals ma. Forwards forces, that's tension, minus backwards forces. Without friction, we just had T1 equals. T1 is the net force. But in this case, I've got 10 newtons backwards that I have to include. And then I've got 5 kilograms, and we know what the acceleration of the system is. It's 5.1 meters per second squared. So I got to go 5 times 5.1. 5 times 5.1 is 25.5. 25.5 newtons on this side. T1 minus 10 newtons on that side. You're going to have to move it over. And it's going to become plus 10 on the right side. And you're going to get T1 equals 35.5 newtons, or you could round your answer to 36 newtons. This is how we find tensions in strings when masses are being pulled along with strings attaching them. Don't be afraid to email me if you have any questions about any step here. And I would suggest you go back and try and do them on your own once you think you understand these problems. I did quite a bit of writing here. And I can help you along if you need help. There's also, where did we had a question like this somewhere in the practice or maybe in the examples. So give that one a try too. And if you can't get it, email me and I'll help you with it. All right, I think that's all. Good luck with that stuff and let me know if you have trouble.